So till now we have seen you are directly entering the values, but there is no reference. A group of values you're entering. There is no reference for them, right? Only values you're entering. So if you want have a reference for every value, so then we can use a map concept. So map is going to have key value pair format. Each key value pair is called one entry. Like that, you can add multiple entries in the map. So then why do you need the map? If you want to search or update or delete the element based on the key, then you have to go for map. So or you want to insert or update the element or delete the element based on some key reference, then you have to use a map. List to set to directly values you're entering. There is no reference. So that is the problem. So you cannot but particular value if you want to update, and there is no reference there. So you have to go either through index or you have to search. So a lot of things you have to do that. But to overcome that, so we have a map. So map is a key value pair concept. So you can enter them and you can update them, you can delete them, whatever the operations based on the key. So key will be there for every value. So that's the map means. So there is a map is implemented. Map is an interface again. It's part of java.util package. These all collections are under java.util package. The collections are in java.util package. So we can implement this map interface in the HashMap, linked HashMap, and tree map classes. So the same as a HashSet, right? Set collection is implemented in the HashSet, linked HashSet, and tree set. Here just map only. Set also works based on the hashing technique. Map also works based on the hashing technique. How it works map, I'll explain you internally. So we'll see that. So map doesn't allow any duplicate keys, but you can have a duplicate values, but no duplicate keys. Keys are always unique. So you can HashMap, linked HashMap allow null keys and null values, but tree map doesn't allow any null key or a value. Tree map doesn't allow any null key or null value. So map can be traversed directly with the for loop or iterator. You have to convert them into a set collection using key set and entry set methods. Then you can iterate them. So that is the how you can iterate the map. And also, so you have a map. So methods, there are a lot of methods are there. So put method, put object key and object value. So put all map, and put if absent. If this key value is not present, then you can insert based on the condition based insertion. So generally you can do insertion with the put method, and you want to join two maps, you will use put all like add all method. So last class we have used, and remove method object key. So you can remove the particular key. If you give the key, entire entry will be removed from the map. That's a remove method. For deletion, remove method. For insertion, put method. For so you want to remove based on the key, and you can do this also, the overloaded method. Key set. So see, this method returns a set collection. That means all the keys from the map it will fetch and stores in the set collection. Entry set, these two are very important. Entry set, all the entries it will store in the set collection. See the set map dot entry. Here is the key value data types. K means is a key data type. V means value data type. So you have to give a data type. Both the data types you have to provide. So it returns set view containing all the keys and values. So this will return all the entries into the map, and that will store in the set collection. Then you can iterate with a for each loop or a iterator method. And this also all the keys will store in the set collection from the map, and you can iterate with the for each loop and normal for loop. Next, clear method. So basically it is used to clear all the entries into the map. You will use a clear method. And then most important, contains value. So you want to check particular given value is present in the map. If you want to search, you can use a contains value. Contains key. So this key is present in the map or not, you can check. Equals method, very important, equals, and there is a hash code method. So these two methods are combinedly used. So equals method will compare the objects, two objects, and hash code method will fetch the hash code value of the object. So, and then we have for each, you can iterate. So using this for each loop, and get method. So get object key, basically this method returns the object, so that contains the value based on the key. Get or default. So key and value default. So default value. So it returns the value to which the specified key is mapped, or default value if the map contains no mapping for the key. So either you can use get method or get or default. So you want to get the value of that. So hash code we just discussed. Is empty method. Is empty method, it checks whether the map is empty or not. Other than that, we don't want much. Values, you want to get the collection of values. You can use values method, and the size method to find the how many elements or how many entries are there in the map. You can find out with the size method. So that's the all the method. What are the methods? Very important method. Put method, put all method, contains key, contains value, remove method, get method, get or default, and key set, entry set. These are the few methods regularly will use if you want to solve map problems. Okay, so make sure you remember them, and the hash code and equals method I'll show you in the coming one more topic. So how to use that hash code and equals method. So while searching how it works, how it is inserting, we'll see that. So Java HashMap. So there is a map.entry interface. So this is the sub interface of a map. So it will be used to access each key and each value. You will use a entry interface. So this is the get key and get value methods. These two are important. So get key is used to obtain a key. Get value is used to obtain a value. So that purpose you can use get key, get value method. And what is HashMap? So HashMap is a class which implements the map interface, and also it is extends the abstract map class. So abstract map is the abstract class, so which extends to HashMap and is implementing these map interface methods in the HashMap. So HashMap stores the entries by using HashTable concept. So basically it's a hashing technique it uses. Hashing means a memory based way of storing. So Java HashMap class contains values based on the key. So HashMap class contains only unique keys. HashMap class may have one null key, multiple null values. HashMap class is a non-synchronized. HashTable is a synchronized. And we'll discuss this HashTable and HashMap for differences. That's a common interview question also. HashMap class maintains no order. So it doesn't maintain any order. You cannot give a guarantee you will get the same order. Whatever the order you inserted, that order you won't get. So it will be a different order. Like a list is ordered collection, right? Set is unordered, set also unordered, because list works based on the index. Set doesn't work based on the index. It is hashing, memory, based it will store the elements. Even hash map also same. It stores based on the memory address, not based on the index. So that's why there is no guarantee you will get a insertion order. So it will be a zigzag order. Okay, so that's the hash map. So the capacity of hash map is 16 buckets. So the bucket is nothing but is just carrying the water, right? Same here, bucketing is storing the data. So with a load factor of 0.75, what is the load factor? Once 3/4 of this 16 buckets data filled, it will double the size. Automatically, it will increase the memory size. So that's this hash map, how it will works and how it will be stored the key value pair. And I'll show you below also what is how internally hash map works. That's another good interview question also. So public class hash map extends abstract map, implements map interface. Same I have shown here, that relationship I am showing here. So this is the key value pair you can place in the hash map. So you are implementing that. It's already implemented. Map is implemented in this hash map class. So these are the constructors, hash map constructors, default, parameterized, and so this one, methods of hash map class. We have seen already, same whatever it is there in the map, same methods here also. So separate methods are not there extra. So okay, if hash map is available, then why do we need a hash set? Both are hash set also same, stores based on the hashing technique, right? Then why do you need a hash set then? If hash map is there, that's a good interview question, this one also. So hash map and hash set serve different purposes, right? The use cases is different entirely. So hash map, the way it stores the elements, and hash set way it stores the same, but the purpose is different. So how you will use hash set, how you will use hash map is different. So let's see when you will use for hash map. Hash map is basically a key value pair data structure. So that allows you to store and retrieve values associated with the keys. Based on the keys, you can store, you can retrieve them. So you have always a reference for every value. That's a hash map. So it associates each key with a specific value, making it suitable for mapping relationship between key value pair. So the common use case for hash map is for storing the configuration settings, cache, representing the relationship in data structures like graphs. So that kind of situations you will use a hash map. So when you need to associate values with the keys, so hash map is a good choice. That's when you will use a hash map. All the configurations and you will define like this. See this? First you declare a hash map and see that this is the key value pair. So Alice is having 25 A's, and Bob is having 30, and like that you can put. So then you can get the values using, so this is the key, right? This is the key and value. So you want to get the age of Alice, you will call get method on this map. So this is the how you can use a map. Whereas HashSet is unordered collection of unique elements. Then there is no duplicates. So set doesn't allow duplicates. It only have unique elements. So unordered collection. Even hash map also unordered entries, but hash set also unordered, but it's unique elements. And also to ensure that the collection doesn't contain any duplicate values. If you want to search, the collection is having any duplicate, so the best option is HashSet. So it is often used when you want to check the presence of element in a collection without regard to its position, then HashSet is a good option. So the common use case for HashSet is including implementing sets and ensuring uniqueness of elements in the collection. So this is a good use case. So when you need to maintain a collection of unique elements, so efficiently check for the presence of an element, HashSet is suitable choice. So HashMap is key value pair formats. If you want to store, HashMap is good. And you want to search unique elements, and the HashSet is a good candidate for that purpose. So this is one set, unique names, new HashSet. So unique names dot add, unique names dot add. You can use like this. So that's the unique names dot contains Alice. Checks if this contains or not. So that's the main purpose. So HashMap and HashSet use both a hash-based data structure. As I mentioned, hash-based means memory-based, they will store the values. So both hash-based techniques only, how they will store. And the thing is, HashMap is used for mapping keys to values. HashSet is used for maintaining collection of unique elements. The choice between them depends on the specific requirements, which one you want. You choose key value pair you want, go for HashMap. Just only values, go for HashSet. Unique elements if you want, HashSet you can use. So that is the both use cases. Configuration settings you want, definitely have to go for map only. Okay, how HashMap works internally? How this HashMap works internally, how it is storing key value pairs. So that's very important. And as I mentioned, map, when you create a map, key and value data type, you give the key data type in the angular bracket generics, this one called generics, right? I mentioned in so already in the previous class. So map, new hash map, angular brackets. So then automatically the 16 buckets will be created in the memory. So only 16 buckets? No, when the 75% filled, the values are filled in the out of 16, and 3/4 is filled, then automatically it's double the size. Again, it will be increased the memory size. So that's how it will store, but let's see how. So, and also we need to understand one more concept here, a linked list. So linked list, as we just discussed, but we didn't use them. So right, this is the one. Linked list stores the data in the form of buckets. Linked list stores the data in the form of buckets. So bucket is nothing but a linked list only. So so each bucket has a linked list data structure again. So see that every item is going to map to another item. So that's the linked list, right? So linked list. So one node is pointing to the other node. One node is pointing to the other node. So that is the linked list means. And this is how you can store a linked list. See, this is the one node pointing to other node, pointing to other. So that each bucket is, the linked list will grow. So once they stored it in the particular bucket, so for example, same bucket is coming, another node will add, another node will add. I'll show you that all this, okay, how it will store. Suppose you just taken, you want to insert the elements with a put method. Then this is the one, map.put key and value. So first, so where it will go, which bucket it will go, how do you know that? So how it will calculate? So this is the structure. First, when you write a map.put key value, first it will calculate the hash code value of this key. So using hash code method. So fb.hashcode method will be called on the key. So you will get the memory address. So based on this memory address, the second step, it will calculate the bucket index. Okay, this hash code belongs to which bucket? So that will calculate the next step. It will calculate the bucket index. So in the 0 to 15, the 12th bucket, suppose you assume that 12th bucket it got. Now this key value pair will go and store in the 12th bucket like this. So 12th bucket it will store. Say a linked list node. This is the linked list node. So it will store in the linked list node. So first when you use the put method, it will calculate the memory address and bucket index in the 2 steps. And then one first node will be here. So same way, one more example, if you take, sorry, one more entry I want to insert. So ld.b, ld is the key and b is the value. Because both are strings, right? That's why I'm keeping in double quotes. Again, first step, calculate the hash code of this key. Suppose you got a 2424. And then second step, calculate which bucket it has to go. So 8th bucket. Now what will happen? So this will go on the 8th bucket. So this is in the 12th bucket. This is in the 8th bucket. So this is the one node, another new node, fresh node, right? So this is another node and this is another node. So 2 different buckets it stored. Suppose if one more entry, let's take one more entry to understand the hash collision. What is mean by hash collision? If the bucket is having already one node, so now the 12th and 8th bucket is already having one node. And again, JVM tries to place one more node in the same bucket. Then JVM tries to place one more node in the same bucket. That is called hash collision. What is meant by hash collision? So the bucket is already having one node. And you are trying to place one more node in the same bucket. That is called hash collision. So how hash collision will work? When a hash collision happens, let's see one more example we'll take. So map.put for insertion, put is for insertion, EA and C. So suppose you got the same 12th bucket. Okay. So this entry got 12th bucket. So 12th bucket, you need to insert this. Now, already one node is there, right? Then how it will place? Now see, let's see that. So JVM checks if same key is present in the bucket or not. Okay. This new key and old key already present in the 12th bucket is same or not. The JVM checks. How it will check? It uses the equals method. So the comparison, one object already there in the 12th bucket and one more object is trying to place in the same bucket, and equals method will check, okay, old object and this new object both are same or not. So that will be checked with the equals method. If same key is present, for example, old key and this new key both are same, what will happen now? Just update the node with a new value. existing value will be updated. Key is same, right? So it will be updated. If existing key and new key both are not same, then so what will happen? One more node will add. So that means your linked list is going to grow. One more node will add here in the same bucket. See, this is how it is comparing. Okay, this new key is equal to already existing key. If it is same, it will update this node only with a new value. Key is same, it will update just value. If not same, see this. If same, this will be updated. If not same, it will add a one more linked list node in that bucket. So that means here linked list is growing. If not same, see, but you are using equals method to compare. So put method, hash code method we used. Every time hash code method will be called internally to check. So the key is, so where it has to go, it will check hash code method. Hash code method will calculate the bucket index. Then it will place in the linked list node. If again another entry got the same bucket index, then equals method comes into picture. That is a hash collision comes into picture, and equals method come and compares. If same, just update the value. So new value is there, update the value. Key is same, so then update. If key is not same, a new node will be created in the same bucket. That's the hash collision, we call that. So basically the entire structure here, see that when you call a map.put with a key value pair, the first step is hash code method will find out the hash code value of the key. Then second step, find the bucket index using hash code, and hash code ampersand length -1, it will calculate the which bucket it has to go, it will calculate the bucket index. Then if hash collision occurs, hash collision means, okay, same bucket it is placing. If it is placing same bucket, then equals method will check, okay, if both are equal, so it will just replace the existing node value. If not equal, it will create a new linked list node in the same bucket. If there is no hash collision, simply go and add it as the first node in that bucket index. So this is the entire summary how the hash map works internally. So, but how can you search, right? The searching will happen in the linked list one by one node. So for example, you have multiple elements in the same bucket. So how it will search? So it will search one after the other. That's a drawback for the linked list. It reduces the performance. So that's the issue. But yeah, still, see, you want to search item 3. See, item 3 here, but you have to compare with the first element to, so where it is, item 1 equal to item 3, or item 3 equal to item 2, item 3 equal to item 3, then it will return this. But otherwise it is checking one by one, right? It takes some time also to get that. If there is lakhs of records, it's going to take a lot of time, right? So that's why it reduces the performance, but it will give you right value. So this is all how we will get the value. How will you get the key value? Again, same procedure. So you will use a get method to get the value. So map.get, you are giving the key, right? You are giving a key. For get method, you have to pass the key. Then first step is it will find out the hash code of this key. Then it find the bucket index. So it find the bucket index. Then so it will go to that bucket and search for the value. So okay, this key is in which node, it will go and search. So that's a linked list, how it will perform the search. So that's a get method you will use. Okay, so this is the how hash map works internally. So these are some of the interview questions. I will just go through this. when int a equal to 20, int b equal to a. So these are some of the interview questions. Just go through this, how it works. Otherwise, we're good here. That's a map, all map related. What is the difference between HashMap and HashTable? So HashMap and HashTable both are used to store the key value pair format. So both are using hashing technique only to store unique keys, but HashMap is non-synchronized and it is not a thread safe. So two threads can't be shared between many threads. So that's without proper synchronization code, you cannot share this HashMap. HashTable is synchronized inbuilt and it is a thread safe and can be shared with multiple threads. HashMap allows one null key and multiple null values. HashMap allows one null key and multiple null values. HashTable doesn't allow any null key or any null values. HashMap is new class. It is introduced in JDK 1.2 and HashTable is legacy class. And HashMap is fast, HashTable is slow, and we can make the HashMap as synchronized by calling this code map m equal to collections dot synchronized map, and HashTable is internally synchronized and can't be unsynchronized, and HashMap is traversed by iterator. HashTable is traversed by enumerator and iterator, and so iterator is used in the HashMap for iteration. It's a fail fast, and enumerator in HashTable is not fail fast. HashMap inherits the abstract map class and HashTable inherits the dictionary class. So that's all about HashMap. So how can you sort the collection, any collection? So you can sort the string of objects, you can sort the wrapper class objects, you can sort the user-defined class objects using sort method. There is a hash collections class. Collections class provides the sort method. So you can use a sort method to sort and provide this for this method, a list you provide it. So it will sort automatically. So there is a comparable and a comparator. Two concepts are there. So comparable and comparator, so also use it to sort the elements, collection of elements. So this is the one. Let me explain the difference directly. Comparable provides a single sorting sequence. So suppose you have in the collection, you have ID, name, price based elements. You can sort only based on one, either ID. So that's the comparable. Comparator, you can sort multiple sorting sequences. So we can sort the collection on the basis of multiple elements such as ID, name, and price. But here only single element based you can sort. Here you can sort multiple elements based, just pass the comparator. So comparable affects the original class. The actual class you have to modify. Comparator doesn't affect the original class. You will write a separate class for every comparator. Comparable provides compare to method. Comparator provides compare method. So comparable is present in java.lang package. Comparator is present in java.util package. So we can sort the list elements, comparable type. So like this, collections is a class. Dot sort, and you provide this list. So it will sort the elements. So we can sort the list elements, comparator by type collections dot sort, list comma, which comparator you want to sort. So you have to pass the comparator. So this is the comparable and comparator, another good interview question, this one also. So there is a lot of interview questions on the collections. So mostly they will ask on the collections only, your questions and whoops. So these are the main areas and exception handling, interview point of view. And programs, always string programs. So either you have to use the map and string methods to solve the any interview programs. So I'll show you a lot of interview programs on the strings only you will get, and you will solve with the map only. And that's another thing. What is the difference between array list and vector? So array list and vector both implement the list interface and maintain the insertion order. You know that. Array list is not synchronized, vector is synchronized. So array list is so increments 50% of current array size if the number of elements exceeds, and increments 100%, almost double the size. So array list is a legacy class. Array list is not legacy, but it is introduced in 1.2. Vector is legacy class. Array list is fast, vector is slow. It is array list iterates using for each loop iterator, and this will be vector is iterated using iterator and enumerator. So that's the